So section 2.4 covers two different topics. One is dealing with the arc length, of which I'm going to talk about first, and the other topic is going to be surface area. All right, so let's take a look at this theorem that we have here, theorem 2.4. The arc length for y is some function of x. All right, so we're going to let f of x be a smooth function over this closed interval a to b. Then our arc length is going to be the portion of the graph of f of x from the points where you plug in a and you get f of a, and to the point b, f of b. And those are open, but that's, well, strike that. There's just two different points. But the arc length is given by this formula below. So we're going to take the integral, a definite integral from a to b, and it's going to be the square root of 1 plus the function, the derivative of the function squared. All right, so let's try to do this with a fairly easy one here. It's just a straight line, so no crazy function going on here. So let's do 165. All right, so we're going from 0 to 2, so our interval is going to be from 0 to 2. That's our a and b respectively. We can calculate those those functions as well. That's certainly like the two different points are going to be the point 0, and 5 times 0 is 0. And then it's going to be 2, and then 5 times 2 is 10. So this is going to be what we're going to do as far as this goes. But our arc length is AL for short. Our A is 0, our B is 2. We take the square root, and it's 1 plus f prime of x. All right, so if f of x equals 5x, then f prime of x is just 5. So we're going to take and then all of this with a dx at the end. Okay, and we can take a step instead. Probably what would be best for notation's sake is just have something like the derivative of 5x, quantity squared in there, and then just have another line. Okay, again, I did the work over here, but it works probably more smoothly to show the reader what you're actually doing from step to step. So I've got the derivative notation of 5x, which comes out to be 5. All right, well, 5 squared is 25, so this is just going to be root 26. And we take the integral of something of a constant, and we just slap an x on it. So this is going to be equal to root 26. I guess I'll put the x in front so as to not confuse where it goes. It's not under the radical. This is going to be evaluated from 0 to 2. And, well, 0 is going to zero it out, so this is simply 2 root 26. And this should be our answer. Now, let's take a look at what this actually looks like, this graph here. So let me draw a graph. Black, that'll work. So this is my x-axis, this is my y-axis. 2, 4, 6, 8, 10. We'll start at 2. And then we'll go 2 this way. We don't need to go any further than that, but that's okay. All right, so we plot the 2 points. 2 points are above here, 0, 0, and 2, 10. So 0, 0 goes right here. 2, 10 goes right here. So this is our graph. Should be a straight line. Let's try to do this a little better. I suppose that's a little better. So we want the arc length of this. Well, if you recall from trigonometry, the arc length is essentially the distance from 0, where 0 would be the x-axis here. So we're looking for arc length that it's traveling this way. Now that is the let's just do this as a trig question. So we note this distance here is 10, and we note this distance here is 2. So the length, I guess the length of this line is what we're looking for. So not actually the spin around. But anyway, we're looking for the distance there. It's a straight line. It's easy to calculate. We've got a theorem that will help us with this. This makes a right triangle. So remember this, a squared plus b squared equals c squared. Well, our c is going to be the blue line, our actual value. We have the other two, so 2 squared will be our, we'll use the 2 as our lower, and then 10 squared equals c squared. This is 4 plus 100. And so this is going to be c squared equals 104, which means c equals root 104, or more specifically, we can pull out, we can divide this by 4 and we get 26, right? 4 times 25 is 100, so this equals 2 root 26. So that's how we would solve that as a trig question. Note this is the same as the actual arc length. So the arc length is calculating the length around. Calculating the arc length in trigonometry is kind of the circle around, but that's not exactly what we're doing here. We're calculating the length that we're going here. So we're looking for this distance. Calculating that.